Greeting to everyone. Myself Monica Chaudhary from IT Department, Acropolis Institute of Technology and Research, Indore. Today we will discuss the topic CPU register, type of register and addressing mode. Okay. First we understand what is the need of register, why we need, and then what is addressing mode and type of buses. Then now come to the register. Register are the storage device which are used to store the data. There are different type of register. First one is the general purpose register, used to store temporary data during program execution. Can hold operand, intermediate result or data value. Example R1, R2, R3. Mostly we have seen move R1. Then what is the meaning of move R1? Means we are moving our data to the register R1. R1 is the name of the register and move is the micro instruction that we are giving to the processor. And what is the main function of GPR? To perform arithmetic logical operation and store the intermediate result. Next register is the accumulator, AC. A special register used in arithmetic and logical operation. It stores the one of the operand and the result. We can say the accumulator store the intermediate result. If we have the command like add B, then accumulator will store the result in the previous with B. Then it will store AC plus B. Use क्या रहेगा? Central to ALU operation. Next one is the program counter. Store the address of the next instruction to be executed. If R1 instruction is executed, then it will store the address of the next I2. Working automatically increment after each instruction fetch. If we are executing I2, then our program counter will reflect to the I3. If there is any jump statement or branch condition is there, then it will point to the that instruction. It will not follow the sequence. In general, it follow the sequence. Suppose that I1, I2 and I3. If I1 is executing, the program counter will store the instruction I2, and if there is a branch statement, then it will store the instruction to the that control. What is the importance of program counter? Control the sequence of execution. It will tell that after this instruction which next one will be executed. Next is the instruction register. It holds the current instruction being executed. Instruction fetched from memory, store in instruction register, decode and execute. Next is the memory address register. It stores the address of the memory location to be accessed. Memory read-write operation, all these are performed using the memory address register. Memory data register. It holds the data being transformed to or from the memory. Data read from the memory, then we will say the store in memory data register. Data to be written, first store in memory data register. Next one is the stack pointer. The point to the top of the stack in memory. It mostly used in function call, interrupt handling, and we use the two basic function of the stack, push and pop. Push for the to decrement the stack pointer. If we have pointer value up to 5 and we have performed one push operation, then our stack pointer will come to the point 4, means it can store 4 more values. If we are performing pop operation, then it will increment the stack pointer. In previous example, I have taken the value of SP is 5. If we have reached to the 4, then we perform one more pop operation, means we are deleting that. Then it will increment the stack pointer and again its value become 5. Next is the index register, used for address modification. Effective address calculation is the main point in this register. How to calculate the register, where we have to go, where is your data store. Effective address is equal to base address plus the index register. Base from where the instruction has been started, and index register is pointing to the that register where your actual data is stored. It used in array processing and loop execution. Base register. It stores the base address of the memory access. It helps to relocate of a program. Status register. It contains the flags and condition which we use to set the ALU operation. For example, 0 for the Z, C for the carries, sign for the S, and O for the overflow. It will help to make us decision in the branching instruction. Next one is the temporary register. Store intermediate data during execution. And if we are getting the confusion between accumulator and the temporary register, accumulator can store the one of the operand and the intermediate result, but here I am saying that it stores the intermediate result during execution. Note, directly accessible by the programmer. Now we have a quick revision of all the register. GPR for the general purpose register. Mostly these registers are mentioned in the form of the short form, like AC for the accumulator, PC for the program counter, next instruction register, IR for the current instruction, memory address register, memory data register, SP for the stack pointer, IX for the indexing, BR for the base address, SR for the flags, and TR for the temporary storage. Next is the type of addressing modes. Means we, by the use of register, we know that our data has been stored somewhere in the memory. But how our processor will get that data, how we are defining that? There are 5 main types of addressing mode. First one is the immediate addressing modes. Mean the data is directly given in the instruction. No need to access memory separately. Example, move A and #5. Here #5 is the actual data that we have to move to the register A. There is no need to fetch the data from any register, any memory data register. Directly operand is given in the instruction. We will move the value 5 to the register A. Next one is the implied addressing mode. Operand is implied, not explicitly mentioned. What does it mean? CMA means complement. You don't have to mention any data. Here you are want to make the already stored data to somewhat change, like complement that. It work automatically. If I am saying that increment the value by 1, then it will increase the store value by 1. Next is the direct addressing mode. The instruction contains the memory address of the data. Means where is our data stored. Example, if I am saying move A, 1000. Here move is the instruction, A is the register, and 1000 is the address where our data is stored. Data is actually stored at the memory location 1000. Next is the indirect addressing mode. The instructions specify a register or memory location that contain the address of the data. Example, move A @R1. Here move is the instruction, A is the register, and @R1 is again the address where we will get the address where our data is stored. Means I am assigning the intermediate. I am saying that A will goes to B. When he will reach to the B, it will get the address where our data is stored. That's why it is known as the indirect addressing mode. Next is the register addressing mode. The operand is stored in a register. Example, move A R1. Here our data is stored in a register and we are moving that register data to the our current register A. Register indirect addressing means our register is holding the address of the operand. Here R1 is store the address where our data is actually stored. Means 2 steps we will follow. Next is the index addressing mode. Is calculating using index register plus base address. Move A 1000 R1. Here 1000 is the base address, and after that we have to go to the R1. It will define some value, then we will add to the 1000, and again we will get some data after adding that, and then we will move that data to the register A. Base register addressing mode, similar to the index mode but uses a base register. Relative addressing mode, address is calculated relative to the current program counter. Now next one is the important, that is the buses, means how the CPU, memory, input and output, all these are connected. We have three types of buses: control bus, address bus and data bus. Control bus has the feature that transfer the control signal, and address bus transfer the addresses, and data bus transfer the data. Direction of the data bus is bidirectional, and the address bus has unidirectional, and control bus is the bidirectional. And the purpose of all these, data bus will use to move the data movement, address bus will locate the selection, will select the location and delocate that location, and the control bus is help to perform the operation. I hope you will get understand all the point. Everything will be clear to you. Thank you so much.